Hi, my name is Jeffrey Rowe, and today I'm going to walk you through a simple and practical solution to address real-time data processing delays caused by Kafka, specifically Redpanda in this case, and how it affects AWS SageMaker's um, machine learning pipelines. This is a common problem when scaling real-time pipelines, and I'm excited to share with you my approach. And let's start by looking at the current architecture and identifying where the issues are. So here's an overview of the current setup. On the left, we have data producers, which could be things like user activity logs, click streams, or IoT data. And these producers feed real-time data into Kafka. Um, and from there, Kafka streams this data to AWS SageMaker, which is hosting machine learning models. And these models use the incoming data to make predictions, for example, real-time recommendations for users. But here's the problem. There's a delay in the pipeline, specifically between Kafka and SageMaker. Um, and this means that the data SageMaker received is delayed. And this can affect the accuracy and performance of the predictions made here. So the big question is, can we identify the bottleneck? Before we do that, here's a diagram, a more detailed diagram, to show how real-time data flows through a pipeline to generate machine learning predictions. First, we got the data from multiple producers, which is ingested by Kafka. However, there's this bottleneck in Kafka. Indicated by a lag, which means the system isn't keeping up with real-time data ingestion effectively. The process data is then sent to SageMaker machine learning endpoint for predictions, but due to the streaming and processing delays, predictions aren't as immediate as they should be. The overall challenge here is reducing the latency across this pipeline to ensure predictions are closer to real time. So, when diagnosing this issue, the bottleneck becomes clear. First, on the Kafka side, there's likely a producer or consumer lag. This could happen if the data producers are sending more data than Kafka's brokers and partitions can handle. Or if the consumers are falling behind because of high data volume. Another possible bottleneck could be how on SageMaker's side, if the models are overwhelmed with a sudden influx of data or are receiving data too late, they might struggle to keep up, especially if scaling isn't properly configured. So we've got two main points. One is Kafka's ability to handle and process real-time data efficiently, and another is SageMaker's ability to scale and process incoming data in real time. My solution focuses on making lightweight changes that solve these bottlenecks without completely overhauling the entire system. The first step is to optimize Kafka. We can do this by dynamically scaling the partitions and brokers to distribute the load better. Additionally, we can tweak the producer settings like increasing the batch size or enabling message compression to reduce the amount of overhead in each in each transmission. The second step is to add a buffer between a buffer layer using AWS Lambda between Kafka and SageMaker, and this acts as a relay between Kafka and SageMaker, especially decoupling the real-time dependency between the two systems. And this means SageMaker doesn't need to process data as soon as it arrives. It can handle it at its own pace while still maintaining a near real-time performance. And finally, on SageMaker side, I'd enable auto-scaling for model endpoints. And this ensures that it can handle spikes in data volume without becoming a bottleneck. And for less urgent data, I'd implement batch inferencing, which processes data in chunks, improving overall throughput. These changes are fairly simple to implement, but it essentially addresses the root causes of these bottlenecks, and can be super effective. So why does the solution work? For one, it doesn't require a complete redesign of the existing system, so it's relatively low effort to implement. Uh, and by optimizing Kafka and adding a buffer layer with Lambda, we reduce the dependency on real-time processing and create a smoother system and a flow of data. And this overall just makes the system more resilient to temporary delays. On the SageMaker side, autoscaling and batch processing help handle high data loads more efficiently, ensuring that predictions stay accurate and are fairly quick. This is great because, the good thing about this is how it balances quick wins with long-term scalability. And here's how I would implement this solution. First, I'd focus on Kafka by scaling the partitions and adjusting the producer settings. And this helps reduce, this basically just reduce lag and ensures that Kafka can handle high data volumes. Next, I deploy a Lambda function as a buffer layer between Kafka and SageMaker. And this coupling step is very important to smooth out the data flow and basically allow SageMaker to process data without feeling rushed. And finally, on SageMaker, I'd enable autoscaling for the endpoints and configure batch inferencing. And these changes would improve throughput. It will also allow the system to scale dynamically. I'd also test these changes in a staging environment before rolling them out rolling them out for production to minimize risk and ensure everything works smoothly. With these changes, I'd expect a lot of improvements. First, we'll see reduced latency in Kafka to SageMaker pipeline. Data would flow more smoothly, and SageMaker would receive it faster and more consistently. Second, SageMaker's throughput would increase, which means faster predictions and better real-time performance for our users. And third, the system would be more resilient overall. It could handle data spikes in data volume, or temporary delays without completely breaking down or impacting performance. And so basically, this approach solved the immediate problem, and also makes the pipeline future-proof for scaling and growth. So to wrap things up, the main issue here is latency in Kafka and SageMaker's ability to handle real-time data. And my proposed solution involves optimizing Kafka, adding a buffer layer between Kafka and SageMaker with AWS Lambda, and improving SageMaker's overall scalability and processing efficiency. My name is Jeffrey Rowe, and thank you for listening. And I hope this solution highlights my ability to understand and solve real-world challenges in data pipeline.